Now we're going to look at how to use a standard normal table to find areas under a curve corresponding to certain z-scores. This is on pages T1 and T2 in the back of your book. It's a big yellow table. I'm going to be using a table from the actual AP exam that is almost exactly like it, it's just colored differently. So the first thing we're going to look at is what percentage or proportion of the observations from a standard normal distribution are less than z equals 0.54. So we're dealing with a normal model that has a mean of 0 and a standard deviation of 1. And since the center of this distribution is 0, and the one standard deviation is right here, 0.54 would be about right here. So I'm looking for it when z is 0.54, and I want to know all the area to the left of this curve. So we know that since 0 represents the 50% point, that this has to be more than half, more than 50%. So if we look at the table, you'll notice on the first page of your table, you'll see z-scores that are negative, and if you go to the second page, you're going to see z-scores that are positive, and we want positive z-scores. Z-scores are given to 2 decimal places. Let's look at this picture up here. This picture shows the probability is the area under the curve that is in gray to the left of this particular z-score. And these areas are the numbers in the table here. The z-scores are shown the first decimal place to the left and the second decimal place across the top. So for 0.54, I'd go to 0.5 and then 0.54, and I would look at this. So what this is telling me that if this is 0.54, this area under the curve is 0.7054, or 70.54% of the data lies in that section of the curve. Okay, so we are going to write then that the probability that z is less than 0.54 is 0.7054, or 70.54%. So this is how we find areas under the curve that are not exactly on one of the standard deviations. Okay, let's look at the next one. What's the probability that z is greater than negative 1.12? Okay, so once again, we're dealing with our normal model. Center is 0, so negative 1.12 is about 1 standard deviation below the mean, and I want z to be greater than that. So once again, we're talking about an area that is greater than 50%. I'm looking for the probability that z is greater than negative 1.12. So when I go to the standard normal curve, or standard normal table, I'm looking at here negative 1.1, and then the second column gives me the 0.2, so this is 0.1314. But if you go up at the top here, and that was the row that I was using, or the column I was using, negative 1.12, this is 0.1314. But I'm looking for this area on this side. So recall that the total area under the curve is 1, so this is going to be 1 minus 0.1314. So if I go back here, this is equal to 1 minus 0.1314, which turns out to be 0.8686. Okay, the next one. What's the probability that z is greater than 3.89? Okay, so 3.89 is going to be way out here. I'm going to have to draw just kind of a little red shading under here. 3.89 is very far away from the center. And if we look on our table, we're going to have to go to the page 2 of the table where we have positive z-scores. And if we go down here, we found out the biggest one we have is 3.4. We don't have a 3.89. The biggest we have is 3.49, which gives us 0.9998. Okay, so what do we do for anything bigger than that? Excuse me. Well, if this is 0.9998, this would be 0.02 on this side. So we know that this has to be less than 0.02. So we can say that the probability of Z being greater than 3.89 is less than 0.0002. Okay, because we know when it was 3.49, it would have been 0.0002. 1 minus 0.9998 for Z equals 3.49. So all we can say from the table is that it's less than 0.0002, which is a really small amount, or less than 0.02%, practically zero. Okay, practically a zero probability here. Okay, next, what's the probability that Z is between 0.49 and 1.82? Okay, so here's 0. 0.49 would be about right here. That would be less than 1 standard deviation. 1.82 is about 2 standard deviations, so 1.82 here. So we're looking at this region in between the two. So what we're going to have to do is look up two values on the table. Look up the probability that Z is less than 0.49. Now you might say, well, wait a minute, it's greater than, but let's look at that Z is less than 0.49 first of all, and the probability that Z is less than 1.82. Because less than 0.49 would be all of this area. Less than 1.82 would be all of this area from here to here. So the difference between the two would give me the red area. So if I take this black area, less than 1.82, minus the blue area, less than 0.49, I'll get the red area. So that's what I'm going to find out. So if you go to the table, I'm going to write the values down, have you check on the table and make sure you get the same values. Less than 1.82 would be 0.9. Oh, I got these backwards. 0.9656. Less than 0.49 is 0.6879. So the probability that Z is in between these two values, 0.49 is less than Z is less than 1.82, is equal to 0.9656 minus 0.6879, or 0.2777. Okay, so we actually just are subtracting two regions from each other. What's the probability that we are within 1.5 standard deviations of the mean? Okay, so that would be that we're within negative 1.5 and positive 1.5 standard deviations of the mean. So we can do the same thing. We can find the probability that Z is less than 1.5 and the probability that Z is less than negative 1.5 and subtract them. So the probability that Z is less than 1.5 is 9332. And the probability that Z is less than negative 1.5 is 0.0668. And so the probability that negative 1.5 is less than Z is less than positive 1.5 is the difference of these two. 0.9332 minus 0.0668, which is 0.8664, which makes sense because within 1 standard deviation of the mean is 68%, within 2 standard deviations is about 95%, so this is kind of in between. Okay, last problem here. No, I guess there's two more problems. A distribution of test scores is approximately normal and Joe scores in the 85th percentile. How many standard deviations above the mean did he score? Well, this is a different kind of a problem because we're given, in this case, the area under the curve, because the 85th percentile means that 85% of the data is below that value. Okay, so we're saying if this is 85%, what does z equal? So this is what we're trying to find, is the z value that cuts off 85% of the data. So when we're looking at the table here, now what we have to do is look in these values and find 85%. So you can see if we look at the first table that all of these values are less than half, which makes sense because we're on the left side of the mean. So right now we need to go in here and find 85%. The two values I found that are closest is 0.8508 and 0.8485. This one is closest, so that's what I'm going to use. So if I go up here, I notice, okay, that is 1.04 standard deviations of the mean. So I'm going to go back here and say then that the probability that z, yeah, I'm not going to write it that way. I'll just write the answer here. So z is equal to 1.04 approximately. Okay, so it'd be, now this one is a little tougher to do on the table because the table only gives us certain areas, and if we're in between, we're probably in between 1.03 and 1.04, but since we're closest to 1.04, that's the one I'm going to use. Okay, in a normal distribution, and by the way, we'll learn using technology how to get a little more exact on that one. In a normal distribution, Q1 is how many standard deviations below the mean. Okay, so if we're looking at a normal distribution, Q1, remember, is the 25th percentile. So if it's the 25th percentile, that means 25% of the data is below Q1. So I'm going to just kind of eyeball what I think looks like about 25% of the area under the curve. So if this is 0.25, then what is z? So we're going to do the same thing. We're going to look for 0.25 in the table in the area part. So we're to the left of the mean, so we're going to look in the places where the z values are negative, and I'm going to look for 0.25. Okay, so let's see here. I'm having trouble finding 0.25. 25, 26, 27. There we go. So I see 0.2514 and 0.2483. So this is 0.14% too much, and this is about 0.17% too little. So it's about halfway in between these two. So I'm going to go halfway in between. So I've got negative 0.67 and negative 0.68. So I'm going to go with negative 0.675 because that's about halfway between negative 0.67 and negative 0.68. So that's my best guess. So before one was clearly closer than the other, here we're about halfway in between, so I'm going to split the difference. And I'm going to say z is equal to negative 0.675. So about halfway between negative 0.67 and negative 0.68. Once again, with technology, then we'll be able to see more exactly what that value is, and that will be our next video, is using technology to do the same thing.